Hi. This time you can see a coil with a small area and few turns of wire placed inside the yoke. Let's drag the slider to the far right to add some magnets to the yoke and create a magnetic field. How many squares are lit up on the flux density indicator? Yes, 4 squares. This gives a measure of how many lines of force are passing through the coil. Which side of the central zero are the illuminated squares? Yes, to the right. This indicates that the direction of the flux is from left to right. Now let's drag the slider to the far left to swap the magnets over. How many squares are lit up on the flux indicator? Also 4. And which side of the central zero are they? Yes, to the left. What does this tell you? Yes, that the flux through the coil is flowing from right to left. Let's return the slider to the central zero position to remove the magnets and the magnetic field. Now let's select the induced electromotive force to see an indicator that will lit up if an electromotive force is generated in the coil. Let's drag the slider to the far right again while you watch the induced electromotive force indicator. Watch the induced electromotive force indicator. Which way do the squares lit up on the induced electromotive force indicator? Let's repeat it. Yes, to the left. As the flux through the coil from the magnets increases, the coil tries to oppose the change by generating its own flux with an electromotive force. This is why the indicator deflects to the left. Increasing the flux from left to right is like bringing the north pole of a magnet up to the coil from the left. The coil generates a north pole at its left end to oppose the approaching north pole. Now let's drag the slider back to the central zero position while you watch the induced electromotive force indicator. Which way do the squares lit up while the flux is being changed? Yes, to the right. The induced electromotive force has reversed because the coil is now generating a south pole at its left end to oppose the apparent removal of a north pole from that end. Lenz's law says that the direction of the induced electromotive force always opposes the change producing it. Now let's move the slider from 0 to the right and back to 0 as fast as you can and watch the induced electromotive force indicator. What difference do you see on the induced electromotive force indicator? Yes, more squares lit up. So, the induced electromotive force is greater if the flux change is faster. In fact, the induced electromotive force is proportional to the rate of change of flux. Let's repeat it. So, by increasing the flux density to the far right and returning it to the zero position in a faster rate, more boxes are lit on the induced electromotive force. This is called Faraday's law. Using SI units, it's expressed mathematically as E is equal to delta phi divided by delta T. So the induced electromotive force represented by capital E is generated when the flux through the coil changes by an amount delta phi in a time delta T. If Lenz's law is included in this equation, it gives that E is equal to minus delta phi divided by delta T. That's all. Thanks for watching.